Okay, we didn't quite get through the 1324 stuff on Thursday, so this will be your Monday lecture. So this is your online lecture, and so we're gonna take a look at probability and odds again. So starting on page 14, we're gonna go over this little section in here. The difference between probability and odd. Probability is used to calculate the likelihood that something will happen as a ratio. So um, probability always goes between 0 and 1. All right, 0 is something that's impossible, like it's snowing in August here in Texas, or 1 would be something that's almost certain or sure, like it's going to be over 100 degrees, right, in August. So a chance, is between 0 and 100%. So it's kind of the same as probability. It's just converted to a percentage. All right, and it looks like she's talking about, it's unlikely to rain tomorrow, so that would be on the lower end of the spectrum, I guess, between, closer to 0 than 1. Anyways, as a number, probability is from 0 to 1. All right, so 1 is something that is going to happen, and 0 something that can't happen. So she's got a few sample probabilities, like, when you roll a dice, if it's what they call a fair dice, you have a 1 in a 6 chance of rolling, any of the numbers. Flip a coin, if it's a fair coin, you have 50-50 shot of getting heads or tails. And like with these balls, she's got 5 balls. If I draw 1 ball, I've got a 4 out of 5 chance of getting a blue one. So it's more likely than not. Odds is a little different. The odds of something happening, it's a number of ways of getting what you can occur to the number of ways it cannot occur. So in other words, the ways I can get what I want over the ways I get what I don't want. Odds are not written as a fraction. Okay, we do this with colons. All right, so the odds of a month being August, let's take a look, are 1 to 11. All right, so basically, if you think about it, your total months, you have 12 months in a year. You have 1 month that's August, and then you have 11 months that are not August. So the odds are 1 to 11. So, and they write it with a colon, okay? The odds of a coin landing heads up is 1 to 1 because, you have one way of getting heads and you have one way of not getting heads, all right? Okay, and that colon there is how they use it, how they express it. Don't express odds as fractions, all right. Odds in favor means you want it to happen. Odds against means you don't want it to happen. All right, so let's do some probability here. All right, so we have some marbles in a bag. We have 4 blue marbles, 5 red marbles, 1 green marble, and 2 black marbles. Suppose you select 1 marble at random, then find each probability. Okay, so my sample space has 12 marbles in it, 4 blue, 5 red, 1 green, 2 black. So the probability that I draw a black marble, so all I have to do is, so there's 2 ways to get what I want, and there's 12 total marbles. So it would be 2 out of 12. If I reduce that, it's 1 out of 6. That's the probability. Since we were just talking about odds, I do want to talk about odds here. Yeah. Let's go ahead and do the odds now with this. So the odds would be the ways to get what I want over what I don't. So just to kind of show you for an example, so the odds, I've got 2 ways of getting black marbles. And I've got, if I count this, I've got 10 others that do not, are not black. So it's 2 to 10. We're going to reduce that. So if you divide them both by 2, it's 1 in 5. Okay. All right. So the odds of drawing, the probability of drawing a blue marble, there's 4 blue marbles out of 12 marbles. So it's 4 out of 12 or 1 out of 3. Okay. And again, the odds, think about it. Odds would be, I got 4 blue marbles, and then I've got how many left over would be 1, 2, 3, 8, right? They're going to add to 12. So the odds would be 4 to 8. Or if I reduce that, I want to reduce that, it's 1 to 2. All right, so I'm going to leave the odds off, but I just kind of wanted to talk about them so you can see how I do that. I just divided each of these by 4, right? All right, so probability blue or black. So I'm going to count how many blue and black there are. So there's 1, 2, 3, 4 blue and 2 black. So that's 6 altogether. So it's 6 out of 12. or if I reduce that, it's 1/2. Okay, probability of drawing a not green marble. So in other words, green prime. So how many, I just got to go count how many marbles are not green. And then we'll talk another way to do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 11 marbles that aren't green and 12 that are. Now, the other way I could do a not, this is actually 1 minus the probability that I draw a green marble. So I could also do 1 minus probability green. There's 1 green out of 12, so it's 1 minus 1 out of 12. And again, that's going to work out to be 11/12. Okay. So if you want the probability of not something happen, it's 1 minus the probability of it happening. So sometimes it's easier to count things that way. So we'll do it this other way. So the probability that it's not purple would be 1 minus the probability that it is purple. Let's see, purple, purple. How many? Purple, wait, whoa, there's no purple marbles in there. Okay, so different kind of situation. How many purple marbles are there? There's 0, right? So the probability of me pulling a purple marble, sorry, I'm flipping back and forth. There's no purple marbles, would be 0. 1 minus 0 is 1. So it's 100%, of course. I'm not going to pull a purple marble because there are no purple marbles in the bag. Okay, so that's a given. Okay. All right, so now we're going to work with some odds. So remember, odds are ways to get what I want over ways I don't get what I want. So a young child is looking at a gumball into a gumball machine filled with yellow, red, orange, and blue gumballs. 10 yellow, 6 red, 18 orange, 20 blue. All right, what are the odds of the following? So what I kind of like to do is I do like the total up there. 10 yellow, gonna make a little chart. 6 red, 18 orange, and 20 blue. And total, I'm gonna add those up. So I have my total. A calculator. So let's see, 20, 30, 48. Let's see, 6. I see 54 marbles, okay? Just keep that in mind. All right, odds in favor of a red gumball. So the red gumballs, there's 6. So there's 6 ways to get red. And the number of ways not to get red would be 54 minus 6, or you could add 20 and 18 and 10. So the number of ways not to get red is 48. Because notice that adds up to 54. That's all the possibles, right? 48. The ways to get what I want and I don't. These should add up to 54. All right, I'm going to reduce the fraction because I think 6 goes into 48, 8 times. So I'm going to reduce both of these. I'm going to divide them by 6. So it would be 1, 2, 8. Those would be my odds. Okay, so odds of either getting a blue or orange. So I'm going to count the blues and the orange. So 20 and 18 would be 38. So there's 38 ways of getting what I want. And there are 16 ways of getting what I don't want, yellow or red. And that should add up to 54. Yes. All right, so that's reducible. What I can do on my calculator, if you don't want to reduce it, type 38 divided by 16, right? And then do math frac. And I get 19 over 8. I guess these were both divisible by 2. So it's 19 colon 8. Odds against getting a yellow gumball. So you have to consider now what I want is not, I want everything, I want to not get a yellow. All right, so not getting yellow means getting a red, an orange, or a blue. So I'm going to add those up. That would be the number of ways of not getting a yellow. 20 plus 18 plus 6. So I get 44. Hopefully that's right. And I have 44 ways of getting what I want, and how many ways of getting what I don't want, which is yellow. So there's 10 ways. And you can see that adds up to 54. Goes into both of those too, I think. So we want to reduce it. All right, so I got 22 to 5. Okay. Okay, odds of getting neither a red or yellow. So I want anything but red or yellow. So I'm going to go back up here to my little list. I do not want red or yellow, so I want orange. So I want basically orange or blue, right? That's the same thing that I did up here. All right, so not red or yellow would be 38. And the odds, the number of ways to get a red or yellow would be 16. And I can reduce that. I'm using my calculator, so I get 19 over 8. Okay, just reduce both of these by 2. That makes sense. Yeah, that's the same as the orange or blue. All right, so those are odds. And again, make sure you reduce it. That was probably the question that you had. And even with both probability and odd, go ahead and reduce, to those terms. Probability is going to be a fraction. Odds is still, it's a fraction that the way that I think of it is a fraction, but you have to put the colon. So rather, don't write, 19 over 8, right? You want to do your colon, okay? All right, so we're going to work some practice problems, and that should fill out my lecture for Monday. So it says you entered your name in a drawing to win one of 25 prizes. There are 12 coupons for a free movie, 6 $25 coupons for a restaurant, 6 coupons for free admission into an amusement park, and 1 gift card for 100. All right, so I'm going to list all these out. So it's one of 25 prizes. So I have 25 prizes, 12 movies, 6 $25 for a restaurant, 6 coupons for an amusement park, and 1 gift card worth $100. So those are all my prizes. All right. And again, they total up to 25. All right. So what are the odds that I win a $100 gift card? So the number of ways I can get what I want is 1. Out of the ways I don't get what I want. So because this is 25 total, you add the others up, 12, 6, and 6, that's going to be 24, 1 in 24. Okay, then I want the odds. I get a restaurant or amusement park coupon. So a restaurant, amusement park, where's the restaurant? $25, this is the restaurant. So I got 12 ways of getting those. And there's 25 options out there. So if I add these other guys up that I don't want, I'll just star them. That's 13. So it's 12 to 13. I don't have to reduce that. All right. And finally, the last thing is, sorry, there we go. The last thing I want to do is, sorry, erase that. All right. Anything other than a free movie. So what is other than a free movie? So that could be the restaurants, the amusements, or the $100. So that's 13 ways to get something other than what I want. So it's 13 to the number of ways to get what I don't want. So that would be 12. Okay. Notice how these add up to 25, a total. Okay. All right, so let's look at another example. It says 17 cards numbered 1 through 17 are put in a box and mixed thoroughly. One person draws a card from the box. Find the probability, so we're back to probability, that the number in the card is an odd number. So I just have to count the odd numbers. So I'm going to sit here 1, 3, 5, 7, 9, 11, 13, 15, 17. So I get 9 of them, right? 7, 9, 11, 13, 15, 17. I get 9 numbers. So it'd be 9 out of 17 total. Because probability is what you want over the total. Okay, prime numbers. Did you know that 1 is not considered a prime number? A prime number is a number that's divisible by 1 in itself, but 1's only divisible by 1, so it's not considered prime. So 2 is considered prime. Let's see, 2, because it's only divisible by 2 in itself. 2, 3, 5, that's prime. What else? 7, 8, 9, 10, 11 is prime, 12 is not, 13 is prime, 14, 15, 16, and 17. So I count 1, 2, 3, 4, 5, 6, 7 prime numbers out of 17 possibilities. All right. The probability that a number is divisible by 3. So let's see, that would be 3, 6, 9, 12, 15. So I've got, and that's it. So I got 1, 2, 3, I got 5 out of 17. Okay. All right, let's take a look at this next. It says a jewelry box contains 5 white pearl rings, 2 gold rings, and 6 silver rings. What are the odds, back to odds, of drawing a white pearl ring from the jewelry box? So there's 5 ways of getting those, so that would be 5. And how many ways of not getting those? Well, there's 2 gold and 6 silver, so it'd be 5 to 8. And that is not a fraction I need to reduce. All right, so we got a deck of cards here. She's drawn it. If you're not familiar with cards, 4 suits, clubs, spades, hearts, and diamonds there. The first card is called an ace, and then jack, queen, and king at the end. So the probability that I get a red 3, all I have to do is know there's 52 cards in a deck. Hopefully you know that, 13 cards in a suit. So the probability of getting a red 3, there's 2 red 3s, one here, so it'd be 2 out of the total number of cards in the deck, which is 52. Now I have to reduce that. It's 1 out of 52 divided by 2. 26. Yeah, 1 out of 26. Okay. All right. All right, and that's it for today. I'm going to put this up on the website, and we will start Tuesday with section 8.5, which is going to be rational exponents. All right, have a good day.